Hello friends, welcome to Shiksharthi. In this video, we shall be discussing ratio, proportion and variation. So let's start. So if you recall in my earlier video number 2, we had talked about some properties of ratios along with proportions. I hope you have revised both the videos. You have gone through both the videos, the first and the second video, so that it becomes easier for you to go further. We'll be doing a couple of videos on ratio proportions because we feel that the chapter is really important and that we have already discussed its importance in the first video. Okay, so in the last video we had left it here, wherein we had talked about if A by B is equal to B by C is equal to C by D, which is just like saying if there are three ratios which are given to you and all the three ratios are equal to each other, so then we will say that they have a common ratio. The moment we say that all the three ratios have a common ratio, now it is just like saying this only. So if I say, so this is nothing but the extension of property number 1, wherein we say that 2:3 is equal to 4:6, let's say, and is equal to a third, and they have a common ratio. So incidentally we are not, okay, if I take it as, let's say 2/3 is equal to 4/6 is equal to 6:9. Do they bear a common ratio? Yes. The moment you convert it into a fraction, you will say that the common ratio comes out to be 2/3. Since all the three are in the common ratio, then we will say that b square here becomes what? Now this b square. Now if I say 2:3 is equal to 4:6, though they have a common ratio, but then the point that I am trying to make here is this is slightly different from this, because here I would say b into b, though this is not a b, but if I multiply these two, 3 into 4, the antecedent of this is multiplied, the consequent of the first ratio is multiplied with the antecedent of the second ratio, such that they give you the same ratio, and the same ratio is 2:3. In that case you will say what? 3 into 4 is equal to 2 into 6, which is 12. At the same time, can I say that 6 into 6 will be equal to 4 into 9, which is a 36? Yes, this is what we have discussed. Taking this discussion forward and talking about property number 14, which is very, very important to be understood by you, because here we'll be talking about whatever we would have discussed till now. So if I'm saying, or if we are saying that A by B is equal to C by D is equal to E by F is equal to 3/2. Let's say we are talking about the same ratio, but here we are not talking as 2:3, here we are talking about 3:2, wherein we know that all the three ratios are different, as we had three different ratios here, but all the three giving us a common ratio like this. In that case, the sum of the antecedents, which is nothing but just like saying sum of the numerators divided by the sum of their denominators, will give us the same ratio. And once I would have discussed all these three properties with you, then as a take-home assignment for today, you'll be proving it yourself, though we have proved it here. So if you just take a look here, we have already proved it for you, right? So once we are able to establish this, point number 2 becomes fairly easy. Now what are we saying in point number 2, which is point number B? A to the power n plus C to the power n plus E to the power n, which is nothing but saying that you are taking n powers of the antecedents or the numerators and then adding them and then dividing by the n powers and the addition of their denominators or consequents. Now this entire raised to the power 1 by n gives us the same ratio, which is 3:2. And the third part. So as discussed earlier, you'll be proving these things because they are very, very important, though we have already proved it for you. And you have fair enough time of going through it, because for the last I would say half a minute or so, this area has been lying vacant. So you can note it down, you can just go through it also, and you can prove it for yourself, right? Taking this discussion forward. Now we are talking about point number 15. Now in point number 15, you will come across questions based on the concept that we are going to discuss. What is the concept here? If the question says that A is to B is equal to 1:2, B is to C is equal to 3:4, C is to D is equal to 5:6, D is to E is equal to 7:8, then based on this piece of information, solve these three questions. Yeah, the question can be reduced also. I mean, they can reduce it till here. For example, they can always give you A is to B is 1 is to 2, B is to C is 3 is to 4. So find out the ratio of A is to B is to C. And then find out the ratio of A is to C. And then thereafter you can make questions on your own. Similarly, they could have given you only 3 ratios. The point to be understood here is, if the question comes with a diagonal symmetry. Now what is diagonal symmetry? The consequent of the first ratio should be equal to the antecedent of the second ratio, which is just like saying A by B is equal to B by C is equal to C by D. I mean, in a certain way you had discussed, but here this case number 13 and case number 15 have something in common. And what is the common part here? Case number 13. Now A by B is some ratio or some fraction. Similarly, B by C is equal to some ratio or fraction. Similarly, C by D is equal to some ratio or a fraction. But all the 3 ratios or fractions are equal. But here, A by B is equal to a different ratio, B by C is equal to a different ratio, and so on. So point number 13 and point number 15 have something in common, and that common part is the consequent of the first ratio is equal to the antecedent of the second ratio, which is just like saying a Z. So which is why I call it as a Z rule. What is the Z rule? You are making a Z out of this. So if Z holds good, then how will you calculate the total parts of A? Then you need to focus on the N rule. What is the N rule? For A, come up till A. For the parts of A, come up till A. So in this case, you will say what? A is equal to 1 into 3 into 5 into 7 parts, or X, whatever you want to use. As discussed earlier, you can put a variable X, or you can say this is these many parts. Similarly, for E you can find out for B, C and D. So for A you need to come up till A, for B you need to come down, for E you need to come down till E. Coming down till E means what? Multiplication of all these parts. So for A you have to come up till A. In order to calculate the total number of parts for E, you need to come down to E. So when you are coming down to E, you will say what? E is nothing but 2 into 4 into 6 into 8 parts. Now what will you do for B? So as we discussed, remember the N rule. So now N, actually I am taking it as a mirror image. So if I take a mirror image of N, so let's say if I am writing this, the mirror image will be somewhat this. Is this correct when I write this? No. So what will be the mirror image? Something like this. Okay. So now what is being suggested is come down till B. For B, come down till B, take a turn for B, then go straight. For B, come down till B, take a turn for B, go straight. So B, how many parts? 2 into 3 into 5 into 7. For C, you'll do the same thing. You'll come down till C, you'll take a turn for C, and then you'll go straight, which is just like saying C is nothing but 2 into 4 into 5 into 7. For D, you do the same. You'll come down to D, take a turn for D, go straight. Sorry. So 2 into 4 into 6 into 7 parts. You can say the same for E. Just come down till E, take a turn for E. No, you need not take a turn because you have already reached your destination. This is the best way in which you can understand this. Yes, I hope it is fairly interesting. Now, there is a lot of insight that we need to put in this. If you want proofs, we can give you proofs as well, but please focus on the basic concepts. Now, if you want us to give you some proofs, you can always put it in the comment section so that we can prove it for you, right? Okay. So, can we calculate now A is to B is to C is to D is to E? Yes, we can. Similarly, can you calculate A is to E? Now, if I had to calculate A is to E from here, we could have simply said A is to E is nothing but 1 into 3 into 5 into 7 is to 2 into 4 into 6 into 8. Now, based on this piece of information, if I have to solve this, which is find out the ratio among A square, BC and ADE. Now, ADE means A into D into E, BC is B into C, A square is A into A. Don't just start off the question based on, hey, I can calculate, I know the total parts of A, I need to square this, B into C, I can just multiply them, and ADE is just like multiplying ADE. Now, please remember that for forgetting the question for the time being, this is just like saying this will have a proportional constant x square, this will have an x square, but this will have an x cube. And we learnt somewhere, where did we learn? We learnt in point number 12 that a ratio will always result in a ratio. It cannot leave a proportional constant. So can you calculate the value of this? No, you cannot calculate. Please don't waste your time on this. So before you begin, here you could have begun easily because you know that the proportional constant remains the same as x in all the cases. But here in such kind of questions, before you begin solving the question, please give it a thought at least. And the thought is, will all these parts have the same proportional constant? If yes, then only you can seek an answer. If no, then you cannot seek an answer. Okay, one of the last thing to be discussed now here is, if somebody suggests, okay, find out the reciprocal ratio of 2:3:4. So please recall in the first video, we had already talked about this. And in the second video also, we had talked about this. Anyway, so what are you supposed to do here? Just take the LCM of all these three parts. Taking the LCM that was suggested here was just multiply all the three parts. And then see, this already has two parts. This requires how many? 3 into 4. So can I say, now this needs to be multiplied with 12. This needs to be multiplied with 8. And this needs to be multiplied with 2 into 3, which is 6. So this is the reciprocal ratio that you get. Finally, you can write it as whatever, simplest form. 6:4:3. Just to check whether the answer is correct or not, just multiply the original ratio with its reciprocal ratio and you should get the answer as an ideal ratio. You know what an ideal ratio is. So if I multiply 6 into 2, 12, 3 into 4, 12, 4 into 3, 12, which is just like saying 12:12:12, which is also just like saying 1:1:1, which is an ideal ratio. That means the reciprocal that you have found out for the given ratio, the answer is correct. Right? Okay. Last but not the least, here we will be talking about some concepts on variation. For this, I will be using a formula. The formula that I am going to use here is the formula that we will be using for some other topics also. And the topics are time, distance, speed, time and work, clocks, calendars, etc. So, we all know that speed is equal to distance upon time. So, can I say, now if I say that speed is equal to distance upon time, can I say speed is directly proportional to distance keeping time constant? Now when I am making a circle here, that means that value is supposed to be kept constant. Please try and understand it like this. Let us say I am supposed to go to a place, right? And the place is 60 kilometers from here and I am driving my car and somebody has told me that these 60 minutes, now I know that the place is 60 kilometers away and now somebody has put a constraint. The constraint is you have to reach this place in 60 minutes. I repeat, I have to go to a place, I have to reach that place by driving my vehicle and somebody has placed a constraint and the constraint here is you have to reach that place in 60 minutes. That means keeping the time factor constant because the time has already been specified. Now, if I increase the velocity of my vehicle, will I reach, naturally, if I increase the velocity of the vehicle, will the vehicle cover more distance in that time? Of course. If I decrease the velocity of the vehicle will cover lesser distance in the same time, keeping the time constant. Right? So this delta here is change. The denotation delta here signifies the change. The change can be what? If you recall, we have already discussed this thing in my discussion on percentages and fractions, wherein there can be only three kinds of changes in life. One is increase, the other is decrease, and the third is no change at all. So delta here signifies what? There could be no change, there could be a change which is positive, and there could be a change which is negative, which is just like saying, I know that there is a place where I need to go, and if I increase the velocity of the vehicle, I'll cover greater distance. If I don't increase the velocity of the vehicle, then I may cover a lesser distance or the same distance. I hope. So we are just involving the element of analytical reasoning here, which makes it interesting. Okay. Now, at the same time, if somebody tells me that, hey, you are supposed to go to a place which is 60 kilometers away. So, now if I increase the velocity of the vehicle, will I take lesser time to reach that place or greater time? Lesser time. So can I say speed and time are inversely proportional to each other, keeping the distance factor constant? And same with their deltas, same with their changes. If I increase the velocity, I'll be taking lesser time, right? If I decrease the velocity of the vehicle, I'll be taking more time. If I don't do anything, I will be taking the original time as it is supposed to be taken. And what is the time that is originally supposed to be taken? That will be calculated by the formula time is equal to distance upon speed. Last but not the least, now I'm supposed to go to a place and somebody tells me, hey, you are supposed to keep your speed constant, right? So more the distance I cover, I'll be taking more time. The lesser distance I cover, I'll be taking lesser time. So can I say distance will be directly proportional to time? Directly proportional. And we are talking about variation. Now the moment you use the word variate, variation can be of three sorts, as we talked about. So delta here is, now variation can be of three sorts. If you try and associate delta with variation, variation may be positive, variation may be zero, variation may be negative. If you were to associate delta with variation. Okay. Now, but we generally, when we talk about variation, we talk about direct variation or we talk about reciprocal or inverse variation. So when we talk about variation, variation may be broadly classified into two parts. One is directly proportional, the other is inversely proportional or reciprocal variation. Okay. So just go through it, form an opinion from the first three videos that we have done on ratios. Thereafter, we'll do greater number of videos so that we are able to take it to its final destination. If you think that something knowledgeable has been discussed in this video, please do not forget to like, share and subscribe to our channel. Select the bell icon and select all so that you start receiving updates from us. If you want us to do some specific videos on specific topics, please put in the comment section so that we can do it for you. Thank you so much. Until next time we meet, goodbye.